It's official. Astronomers peering at the atmosphere of Venus have directly detected clear signs of atomic oxygen in daylight, hanging about above the planet's toxic clouds. Atomic oxygen is known to exist in the planet's atmosphere, according to theoretical models, and has even been directly detected on Venus's night side. But the dayside detection means we have a new insight into the dynamics of the Venusian atmosphere and the circulation patterns therein. Venus is a world that scientists are itching to study in greater detail. It's similar to Earth in many ways, but utterly hellishly different in others. Its mass and composition are like Earth's, but where Earth is lush, verdant, wet, and crawling with life, Venus is a death pit. It's cloaked with thick, choking clouds, mostly composed of carbon dioxide, creating a greenhouse environment that leads to average surface temperatures around 470 degrees Celsius, 878 Fahrenheit. Those clouds drop acid rain on Venus, and the entire atmosphere rotates around the planet at a tremendous rate. Winds far below Venus's cloud tops can scream along at around 700 kilometers per hour, more than 400 miles per hour. On Earth, the highest wind speed ever recorded was a hurricane gust of 407 kilometers per hour, 253 miles per hour. We don't know how Venus and Earth ended up so very different from one another, but studying our neighbor could help us figure it out. Was Venus once on the same path as Earth and took a wrong turn somewhere? Or was it the evil twin from the start? Understanding the atmosphere of Venus could help us understand the differences between it and Earth. And one of the ways to do that is by following the oxygen. Atomic oxygen isn't like the oxygen that you breathe. The latter is molecular oxygen, or O2, consisting of two oxygen atoms bound together. Atomic oxygen consists of single lone oxygen atoms, and it doesn't tend to last very long because it's highly reactive and easily bonds to other atoms. Here on Earth, it's abundant at high altitudes, where it is created by the photodissociation of molecular oxygen. Basically, solar photons break apart the atmospheric O2. A similar process is thought to take place on Venus. Venus's atmosphere is predominantly carbon dioxide. When light from the sun hits this CO2, photodissociation splits the molecules into atomic oxygen and carbon monoxide. The carbon monoxide is also subject to photodissociation. When these atoms travel around to Venus's night side, they recombine into carbon dioxide, a process that causes the planet's night side to glow. Atomic oxygen has been observed as part of this process, but had never before been seen on the dayside. Physicist Heinz Wilhelm Hubers and the research team utilized the Stratospheric Observatory for Infrared Astronomy, SOFIA, flying high in the Earth's own atmosphere, in the terahertz wavelength range that straddles microwave and far infrared. On 3 separate occasions, the plane flew, collecting data on 17 locations on Venus, 7 on the dayside, 9 on the night side, and 1 at the terminator. At all 17 locations, the team detected atomic oxygen, peaking in concentration at an altitude of about 100 kilometers, 62 miles. This corresponds to an altitude that sits directly between 2 dominant atmospheric circulation patterns on Venus. The powerful, super-rotating flow below 70 kilometers that rotates counter to the spin of the planet, and the subsolar to antisolar flow in the upper atmosphere above 120 kilometers. This means that atomic oxygen represents a heretofore untapped resource to probe this atmospheric transitional zone on Venus. Did life exist on Venus in the past? Venus is the hottest planet in the solar system, even though Mercury is twice as close to the Sun and receives 4 times more solar energy. At the surface, Venus has average temperatures of 470 degrees Celsius, 878 degrees Fahrenheit, hot enough to melt lead. With that extreme heat and crushing atmospheric pressure, the surface of Venus today is one of the deadliest environments in the solar system. Venus is so hot because of its thick carbon dioxide atmosphere, which traps heat, creating a runaway greenhouse effect. 54 times more dense than Earth's, it is the densest terrestrial atmosphere in the solar system. The atmospheric pressure on the surface of Venus is about 92 bar, or 1,350 pounds per square inch. This is the equivalent of the pressure you'd experience if you were a kilometer, about 0.6 miles, underwater on Earth. Although Venus is a hellscape today, it likely used to have similar conditions to Earth: oceans of liquid water, a mild climate, and other characteristics that may have made it habitable. Past missions to Venus have found evidence of granite-like rocks that would have required the presence of water to form. Because of hints like this, some scientists think the planet may have had liquid water on its surface for 2 billion years. Because liquid water is the key to life as we know it, if Venus had water on its surface for billions of years, it's possible that microbial life emerged during that time. We don't know for sure though, and looking for evidence of past life on Venus is almost impossible with current technologies. Although orbiters can teach us a lot about a planet, to search for signs of past life, we need to take a much closer look. On Mars, we look for past microbial life by sending rovers like Curiosity and Perseverance to analyze rock samples. But Venus is a much more difficult place to explore on the surface. Only a handful of landers have successfully operated on the Venusian surface. Many more have tried and failed, but even the successful missions were only able to operate for hours at most, before being destroyed by the planet's extreme conditions. This doesn't give spacecraft enough time to do things like collect and analyze rock samples to look for microscopic fossils. Understanding Venus's atmosphere could be key to unlocking the mysteries of our solar system and how Earth's closest neighbor became so wildly different. Was Venus always the inferno it is today, or did it diverge from a path similar to Earth's? This discovery brings us one step closer to answering these cosmic questions. Stay tuned for more space discoveries and unravel the mysteries of our universe with us. Don't forget to like, share, and subscribe for more exciting updates.